let's talk about value engineering and the design review process. So, when you bring someone in to talk about process, people get the wrong idea. You could have all the process in the world, and if the wrong people are executing the process, then it won't work. Like if you say, we're going to bring in the standard government design review process. We're going to have preliminary design reviews. We're going to have critical design reviews. But if you staff the room with first-year engineers or any kind of yes men or someone who's inexperienced, the results of the process won't be good. So the first step to executing on ISO 9001 or Lean or Six Sigma or anything is to have people on your team with the correct experience. You could have a lot of experience and it might not be good experience. So yesterday, after thrashing hard, playing in reverse, like cleaning out the whole backyard of like wood with nails poking out of it and hanging cabinets and just fucking thrashing hard, dude. Doing the gnarliest of work. I dropped in to a side gig to repair a powered woofer. This is one of those all-in-one DJ woofers. They're really popular. You can just plug a mic or a audio into it, and it's got the amplifier built in and all kinds of preamp features. So this was a refined product. It had gone not just through design, but through value engineering, and I could tell. And so let's take a moment and talk about what it means to have the right people in the room when you're doing your design reviews. So most commonly you'll have a talented mechanical engineer or two or three, and you'll have a leadership team who are just focused on budget and schedule and landing contracts, shit like that. You'll have an electrical engineer or two or three, and let's say you've got a somewhat clunky product and it's time to, you've got a bucket of money to, say, bump your production by 10x or 100x, and while you do that, you want to make everything, you want to make a pass over everything. So of course you've got your list of things that are, requirements, and you have your list of things that are desirements, and you need to, execute on those. So to pick on this particular product, it had a blown fuse, and the fuse was totally and completely inaccessible. And sometimes that's done on purpose, and if you really know the product, I can get into it quick. Like with a gun, 1 minute flat, so it's not impossible to fix, but certain parts were glued in, as probably a late stage process. I doubt that was part of the design. I finally got to this fuse, and it was soldered to the board, and I had to swap it. So somewhere in there they had a major redesign, and I can almost picture how it went. The people in the room, I can assure you, they probably didn't have customers in the room or someone representing the repair staff in the room, because what was missing was not designed for manufacturability, but designed for troubleshooting and repair. So when you're designing something that's slick, what will happen is your mechanical engineers will come up with all these smooth lines and clever click-togethers, in order to meet their volume requirements and break things up in the modular way they're supposed to. Usually quality or test will be in the room to make sure that things are accessible for manufacturing test, right? And this particular product had all the signs of that. The whole amplifier and preamp unit attached by only one 8-pin Molex. a 2x4. And so that means that, I could just take that module and test it standalone. And I could also test the woofer system standalone, and that's great. But somewhere in there, when someone was stuffing all the circuit boards, they did really stupid things. Like, it goes together. If you were putting it together for the first time and you did it in order, it's fine. Like, I can tell that the AC block has to go in first. But once it's a full assembly, you can't access the fasteners for the lower assemblies without a complete disassembly, which I guess in some ethos that is all right. But there's something we call tool path, and that's that if you put a fastener in something, you must provide a proof that you have a path to that fastener with the tool that isn't cocked over or fucked up or requiring some, like super fiddly, turning it an eighth of a turn at a time with like, a weird Phillips right-hand screwdriver. That kind of shit is bullshit, right? So when you're setting up your process, when you're setting up design review, you always want to have a Joe the plumber in the room, just a dude who has to work with it, so he can show you that you might be saving 5 cents right now, like at time of manufacture, but at time of repair you're lowering the perceived value of your product because you make it expensive and hard to repair. Like, say this thing's only $1,000, it might cost someone $400 to repair it, because it's a 3-minute repair that takes 3 hours to execute on, because you have to do a total teardown. And when you do that, you're putting cycles on the self-threading screws. These are the plastic screws that cut into plastic. All kinds of different length fasteners and no indication as to where they go. You're scratching up the customer-facing painted fasteners because, you have to take out like 32 of them. Like, there's just things you can do that are stupid and things you can do that are smart. So this particular unit, I didn't want to do a full teardown. I just wanted to check the fuse. And, maybe it was because of late changes to pass EMI, but you remove like 10 fasteners and this thing comes away, and it's pretty slick, though it looks to me like it would rattle. You then remove a bunch of like, the first thing you remove is a ground joiner. No one would know that's what it is, but I know that's what it is, to make a continuous shield. And then you remove a plastic cap, and inside is a big circuit board. Everything's all mounted to standoffs and screwed from the front and the back. It's a bunch of clever. It's good. But then you get to the AC filtering section, which is just some capacitors and inductors. It's like some choke filters to make sure that it doesn't blast noise back on the AC and that the AC noise doesn't get in. It had a cage over it, and it was like, okay, and it required nuts instead of screws, and it was like, oh, okay. And then it wouldn't come off because next assembly, because of the way they bent the sheet metal, next assembly was a fucking jam, right? So I was actually able to get it apart without a total teardown, but only through experience, like tweakery. Like, basically I knew how much the metal could bend without yielding and taking a set, and I knew that I could rub against the side of the PCB board because I could see the perforations and I wasn't going to harm it, and I knew what was underneath, and I was able to jimmy this thing off. And then I found the fuse and I swapped the fuse, and I'm putting it back together, and there's 5 fasteners, and 2 of them are completely inaccessible. Like, you cannot get the tool on them. And so it's like, fucking, like, what is that? Like, in order to get the tool on these 2 fasteners, I was gonna have to remove like a 24 fastener assembly with all kinds of fucking buttons and dials and little screws, and it was just like a non-starter. And so I jimmy this cover back on, and then it requires 2 nuts way down a hole. And it's just like, dude, who does that? Like, I know why they did studs right there with nuts, because of the just because the way it was set up, you couldn't necessarily have screws coming in from the back in that particular spot. It would have been, in the way of all of the user interface. But, I put it all back together, and I'm just thinking while I do it, like, when they had the design review, I could picture the model spinning around and how cool it looked, how slick it looked, like just so smooth, but only internal. Because no customers are ever going to see it. Like, if you took this apart as a consumer, you'd be so fucking sorry, dude. Never get it back together right. You fucking break it on the way back in. So this really slick design they made is only seen by themselves and their repair shops. And then I promise you, the minute the repair shop gets as far as I got, they're just cursing you out for designing something that's stupid. You have like a blank slate and you can design something which is easy to repair. An example of this would be Swanson. They know how to build something for repair. I'm still using Swanson power supplies from 1991. Like, the original stamps are on there. Think about it. Decades, because it can be repaired. You can get to the tops of the PCBs, you can get to the bottoms of the PCBs. It's built for service. You can replace the AC caps, you can replace the DC caps, you can replace the fans. They give you a schematic with a list of fucking part numbers, values, and power, like quarter watt resistor, 1/8 watt resistor, right? They want you to keep it in service. So in Swanson's design review, I could tell that they had at least some kind of representative, like a representation of Joe the plumber, the guy who's going to work on it. And they ended up with a product that stood the test of time for decades. But this particular product I just took apart, it's probably a clone of something far more expensive. I haven't checked the market, but I would imagine the real deal could cost you $3,200 if you just walk into Guitar Center and grab it. And these, will give you comparable performance. Maybe they're $1,200 or $2,000. But the trouble is all it, it allowed itself to blow a fuse, and all I wanted to do is check that fuse and swap that fuse, and it involved hours of disassembly and reassembly. And granted, if I did it all day, every day, yeah, I'd know the tricks of exactly how to do it. But nobody's just sitting around waiting to work on your one little thing and its peculiar little, nuances. Like, a repair shop is repairing 20 different brands, and they just happen to be certified to repair the brand you have, right? Unless you're sending it all the way back to the factory. It's like, just, if the world could change in one way for Schindler, would you please do mechanical engineering, put a block in mechanical engineering for toolpath, where even if you have to 3D print all the parts, just have someone try to take it apart and put it back together. Because, like, the economic model doesn't end when you're done assembling it on the production line. It carries through into the field. And this is, I'm especially sensitive to this because of automobiles and fucked up decisions that have just ripped my skin off, and fucking broken my back and cost me so much time to do something that's relatively simple, like changing an alternator, right? That can be a 15-minute job, even in a tight engine bay. But if you put the alternator underneath the power steering, and you put the power steering underneath the fucking, MAF sensor, and you put the MAF sensor underneath a bunch of plastics, and it's all fucking tied together to look cool in a 3D model, but the fucking tool paths aren't there, well, you take a 15-minute job and you make it an hour and 45 minutes. And when you're charging $150 an hour, it adds up. Like, the cost of labor can easily eclipse the cost of parts on most repairs now, because things are computer designed with the incorrect quorum in the design path, such that they're thinking of their CAD masturbation, right? Like, I get it, it's a hard job, but that's the fucking job of engineering. It's to meet the requirements of all the customers. And one of the customers is the person who has to maintain it once it's in the wild, right? Not just like design for manufacturability needs to include design for repair, unless it's a throwaway item. And who the fuck wants to buy something for $2,000 that breaks and then throw it away when it breaks and go buy another? See, that's dickhead economics. Right? That's what the guy's thinking. He's thinking, well, I don't make any money off this being repaired, so why would I fucking want to make it easy to repair? In fact, I'd want to make it hard to repair, so you got to buy another, because you could buy 2 of ours for the price of one of theirs. Well, the truth is, if you buy one of theirs, it's not going to break in the first place, right? Because they're going to have tested it enough to work out some way that will stop you from breaking it. Yeah, so I was only able to get 3 out of 5 fasteners back in. Otherwise, I'd have a perfect reassembly, which is fine. You know, it was excessive fastening. Usually you'll find that on anything that's a late change, like say you don't pass regulatory, you don't pass EMI, and so you bring in your EMI guy, and he has his way of doing things. He has his little cage, and he has his little, you know, Faraday cage joiners, and he has his little studs, and he has to, you know, he's the one touching the AC, so he wants it done in a way that he knows will pass, and, you know, it doesn't necessarily go in well. Anyway. Yeah, so in the government and medical, you have a design review process, 4 or 5 steps, you know, like a preliminary, I don't remember all the steps off the top of my head, but a big one is a preliminary design review, and another one is a critical design review. And following the process is far less important than having a quorum, the correct quorum, to decide whether or not you're going down the right path. Yeah, so I fixed this thing, put it back together, and I'm imagining there's probably a lot of them available on eBay that are, this one was lights out. It did nothing. I mean, the fucking AC fuse was blown. Like, literally, this is Euro wires. There's a brown wire, a blue wire, and a yellow-green wire. Yellow-green wire went to chassis. Blue wire passed through. Brown wire came in, went through a switch, which was glued in, and I could hear it sparking. That won't last. And then hits the PCB board and goes through a fuse. So, you know, of course nothing worked. I lap soldered a fuse underneath the board across the pads. It was a very simple PCB, little 2-layer, you know, really cheap, simple PCBs. Yeah, so I imagine that just kind of like the Sorensen supplies come up a lot because people are just too lazy to just download the manual and see how to fix it. Once the fan starts buzzing, or the fan stops working, or the AC caps dry out, or someone steals the DC caps, or fucking someone drops it and twerks the case, they don't want it. And so, you know, a $2,000 instrument can be had for $200 quite regularly. We got 5.0 with the blue lights on over here. So I'm thinking maybe I can pick up 4 or 5 of these things and play mix and match on parts. All it has is the AC filter section, the preamp section, and then a totally separate amplifier section. The amplifiers, you know, unless something radical happens, you can usually swap a transistor or a MOSFET and get them working. It's possible the caps can dry out if it's a bad batch of caps. Like, a bad batch of caps just means mislabeled. Like, they were labeled as 25 volt, you know, 105C, and really they're like 16 volt 60C caps, and they just fucking cook off. You just gotta unsolder them all and solder new ones in that are much more expensive, you know, low ESR, voltage with margin, you know, quality, like $5 capacitors instead of 5-cent capacitors. And that's what happens in a value engineering, is they replace, you know, 50-cent parts with 5-cent parts, where the good brands use $5 parts, and then the knockoff brand uses 50-cent parts, and then the value engineers use 5-cent parts. And what happens is, instead of lasting 25 or 30 years, it lasts like 2.5 years. Or, you know, you can count the fucking hours. Like, literally, like after 2,000 hours, those caps have burnt off their life and they die. So I can fix an amplifier. A preamp, there's no reason for it to break, dude. So if it does, it's probably like got smashed and a dial is broken off. And that you just need a pack of known good parts for swappers. And the AC filter section, there's nothing in there but like 4 or 5 capacitors and a couple giant toroids, and it shouldn't break, dude. Other than the fuse, which is in the fucking buried. Ridiculous. I think it might have been a counterfeit fuse. It had the correct markings, but you can get batches of fuses that are non-compliant, you know, cheap on the gray market. Don't ever buy anything on the gray market. It's been serious for the last 20 years. Like, parts pedigree, dude, you cannot buy gray market parts. They literally are not what they say they are. It looks like it, it smells like it, it was actually made in the right place, but, you know, somebody put 2 scoops of flour instead of 1 scoop of flour into the pot when they fucking made it, and it tastes like butt dust. It don't work. Trouble is, it does work, sorta. You don't want to go down that path. Yeah. So, tool paths. Value engineering has to happen to make things affordable for us, but there's 2 kinds of affordable. There's the Amazon, you know, click-through metrics for affordable, for items which are designed for obsolescence, and then there's affordable. Like, yeah, it costs you a little bit more up front, but it lasts 25 years. So, you know, when you're talking about a cell phone that is changing, you know, radically, like 30 to 300% year over year, you don't need to focus on design for manufacturability. But with something like a stereo or an automobile, you know, the technology just isn't changing that fast. It doesn't pay to scrape $20 out of the bill of materials and then cause the consumer to have to spend $200, you know, just to do a repair because it takes so long. So this feeds into the 10x rule of manufacturing, and, you know, some value engineer literally saves 20 cents, and it literally costs you 2, 3, 4, 5 orders of magnitude more to deal with that. And it's passing on sorrow to the consumer, and 99.9% of people aren't gonna fucking get it, dude. Like, you have to be in engineering and in manufacturing and in repair to appreciate the fucking nuance that these are just decisions that are made. So generally the way it shakes out is people with money just buy the best, and it is the fucking best. It's the best parts, and it's serviceable, and it's documented, and you can, you know, get a hold of those documents either legitimately or illegitimately, and, you know, first, it doesn't fucking break, and when it does, it does for good reason, and you can fix it. So when I'm talking about, you know, society going the wrong way, that's like, life is a ship, dude. Think of it that way. It's a ship, and we're in the busiest fucking port in the universe. There's 1 trillion ships all fucking zipping like mopeds in the Philippines, dude. Zipping left and right everywhere. And so everybody's a captain. And we currently, in our society, especially, dude, in tech, we put people at the helm who are focused on penny-wise, pound-foolish things. You know, short-term value engineering, like make it cheaper to build, because they're trying to like shave $5 off the cost to undercut the competitor. And, you know, they're focusing on a sort of marketing, which is marketing to the wrong people. Like, if you want to market to people, why don't you educate? Whoa, bro. This guy just fucking straight up blew a red light in a leaf. I was in the green. The guy next to me was in the green, and he just fucking drove right in front of me. Educate your customer base on the value of your product. Not because your product's cheaper, but because your product is either reliable or cheap and easy to repair. And, Honda and Toyota nailed both. They are both reliable and cheap and easy to repair. But once you start repairing a Honda, you'll realize that when they're really, really nice parts go end of life, the parts you get at AutoZone don't last as long. Like the original Honda alternator might last 200,000 miles, and the AutoZone alternator might only last 30,000 miles. And that's fine, so long as it's easy to repair and cheap to repair. I don't mind having to repair something over and over, so long as I get a reasonable service out of it that's predictable, like 100 hours or 1,000 hours. And when it's time to repair it, I can just slap it in there, pop in a cassette tape into the old stereo. But don't make things that are like throwaway. It's not honorable. Like a Honda, a Toyota, a Lexus, an Acura, a Mercedes, a BMW, a Nissan, an Infiniti. These are not throwaway items. They're durable goods. A tractor, durable goods. A gun, durable goods. Right? Think about it. The sun is blasting through the clouds on the mountains, and they just have little patches of green left, and they're all brown. It's really fucking popping today. Have the right people in the room when you perform your design review. Don't silo up. Whoa, what the fuck, dude? What is going on today? It's fucking crazy day. Yeah, think about the full life cycle of your product. So, I've been on a fucking winning streak, dude. Big. I'm trying to think of the difference between now and 10 years ago. The difference is now I'm more familiar with AC design, analog design, digital design, how to swap parts on the board, how to trace PCB. Basically, all my laying out of PCBs and reverse engineering of PCBs has paid off. Like before, I couldn't solve something because I didn't recognize something was a fuse that didn't look like a fuse. Like, not all fuses are a little glass tube or like a ATO style. They could look like anything, and you have to be able to interpret the silk screen on the PCB and not be scared, know what you're looking at and fucking change it.